Welcome back, Marauders.
This video 16.8, we're looking at the relationship between Ka and Kb. So we've looked at Ka before, and so Ka for HF, hydrofluoric acid, happens to have a value of 6.8 times 10 to the minus 4. So that tells us how strong the acid is. That tells us that when HF acts as an acid, HF plus H2O reaches an equilibrium, so the acid gives its hydrogen away, so it makes the fluoride ion, and it makes hydronium, H3O plus. And so this equation right here has an acid dissociation constant of 6.8 times 10 to the minus 4. So it tells us that it's a weak acid. It favors mainly the reactants. Some of it becomes products, but a lot remains as the reactants. So here's our acid, water's the base, and then over on this side we have a conjugate base and conjugate acid. So we know that the fluoride ion can act as a conjugate base, and so what we're looking at now is we're trying to find a Kb value for that conjugate base. So let's write another equation where fluoride acts as a base, and so that will react with water, and we know that bases accept protons, so the proton will move on to the fluoride ion. And this will reach an equilibrium, making HF, and if water loses a hydrogen, it'll be OH minus. So this is an equation for the fluoride ion, which is the conjugate base of hydrofluoric acid, acting as a base. And the equilibrium constant for this equation is Kb. So the relationship between Ka and Kb is that Ka times Kb is equal to Kw. So we know Ka in this case. Ka was given as 6.8 times 10 to the negative 4. We want to try to find Kb, and they're equal to Kw. So that is 1 times 10 to the negative 14. And when we solve that, we find out that Kb is equal to 1.47 times 10 to the negative 11. So that equilibrium constant is really, really small, meaning that a very small fraction of it will become the products, and it's a very, very weak base. So the fluoride ion is a base, but it's a very, very weak base, and you can tell that because the Kb constant is very, very, very small. But anyways, this is the equation that you need. It's the relationship between Ka and Kb. So if you know Ka for a weak acid, you can find the Kb for its weak base, and vice versa.